Now we're going to dig into radical equations, and as we do that, I just want you to do some thinking here. So I'm going to pose the question, how could we solve something like this? And so I want you to pause the video, take a moment and think, how would you solve something like this without me telling you? Okay, well, if it was me, I would likely move the 2 to the other side. So I'd have 4th root of x squared plus 8x plus 7 all underneath the 4th root is equal to 2 on the other side. And then, well, I know this is really an exponent, so this is really, okay, if I'm going to erase that, that's really saying to the 1/4. And then I want to undo this exponent, so I'm going to raise each side to the 4th power. I can do that as long as if I keep in mind whatever I do to one side, I have to do to the other. Okay, and then I get 8x squared plus, x squared plus 8x plus 7 is equal to 16, and then I can go for it from there. Okay, that's an idea. Okay, for the next one, again, I want you to think about this one. Square root of 1 minus x minus 1 is equal to x. Okay, and I want you to again pause the video, think about how you would solve that. Okay, well, again, I would likely move the 1 to the other side, so I end up with something like square root of 1 minus x is equal to x plus 1, and then I would undo the square root by squaring both sides, and 1 minus x is equal to x squared plus 1, and that's a complete mistake. But I bet some of you still like to do this. This is called freshman's dream. This is what every freshman in college believes is true with math, but is never actually ever true. Remember, you cannot distribute exponents across addition. So instead, what you would have to do is recognize that x plus 1 squared is the same as x plus 1 times x plus 1, and then go ahead and distribute that all out. You get x squared plus 2x plus 1, and then you can go for it from there. Okay, so now if we kind of look at the common patterns as far as what we ended up doing to solve these, really what we started with is we isolated one radical expression to one side. So we isolated a radical expression on one side of the equation. Okay, so here I'm just going to follow this example down. So 1 minus x, so I would add 1 to both sides here. So now in this first step, my radical is completely isolated. Okay. Next, once I'm at this stage, what I ended up doing was squaring both sides, right? And so that just means that I have to raise each side of the equation by the power necessary to cancel the isolated radical. So again, this is a square root, and so it's a 1/2 exponent. I would cancel the square root by squaring both sides. Okay. And then in the subsequent steps here, okay, we would simplify the equation. Okay, so let's just go through this. 1 minus x is equal to x, well, and then I expanded it previously and got x squared plus 2x plus 1. Okay, but now I would have to look at this thing, and in some problems, not this one, but in some problems, you might have radicals existing yet despite your squaring efforts. And so what you need to do is, again, repeat steps 1 and 2. So isolate the radical, raise each side by the power necessary to cancel the radical, and repeat that until you have no radicals remaining. Okay, but you always need to re-isolate the radical. Okay, and from here, it's really solve this polynomial equation. So get everything to one side. 0 is equal to x squared. Let's say I would add an x, and subtract a 1, and subtract a 1. Okay, and if I do that, I get x squared plus 3x. And then, oh, we're good at doing this, x plus 3. Okay, and then I get x is equal to 0, or x is equal to -3 by the zero product property. Okay, and so then those are my answers, and I would say, yep, those are my answers, but wait, you got to check your solutions. And this is extremely important now more than ever, because the reason we have to check our answers is because when we introduce when we introduce an exponent, when we square, cube, fourth, whatever, we are raising the degree of the polynomial, so we may be introducing more solutions than we actually can have, and those are called extraneous solutions, and we would need to discard those. So if I check 0, okay, so I'm just going to write the original expression out. 1 minus x minus 1 is equal to x. I'm just going to check this in here, so you don't necessarily need to show the work. I'll mention what you need to show in a moment. Minus 1 is equal to 0, and sure enough, this is true. Square root of 1 is 1, minus 1 is 0, and then, so that one works, so I would just say, do this and put a check mark if you don't want to show the work. And then for 3, I would do 1 minus 3 minus 1 is equal to 3. This one, that's the square root of a negative. That's not going to work. So actually, my only answer here that I would report is x is equal to 0. Okay? So again, this plan of attack generally works when you're solving radical equations. Make sure to review this, and then in the next video we'll go through some more examples.